Of this video says the end of aluminum. That sounds dramatic, maybe even a little crazy, but by the time this video is over, you're going to understand exactly why we said it, and you're going to agree. Because what Xiaomi just did to the way cars are built makes standard aluminum look like something from a museum. Picture this. It's the year 2021. A company famous for making cheap smartphones, air fryers, and electric scooters walks into a boardroom and says, "We're going to build a car." Not just any car. A car that will lap the Nürburgring faster than a Porsche. A car stiffer than a Bugatti. A car where the chassis is printed, not welded, in under 2 minutes per section. The room laughs. 3 years later, nobody is laughing. The Xiaomi SU7 Ultra exists. It's real, it's on the road, and it just ran the Nürburgring in 6 minutes and 46 seconds, beating the Porsche Taycan Turbo GT by several seconds. And the craziest part isn't the speed, it's how they built it. Xiaomi didn't just make a fast car. They threw out 100 years of car-making tradition and started completely from scratch. No traditional welding, no stamping hundreds of steel pieces together, no giant baking ovens. They used artificial intelligence to invent a brand new metal that has never existed before, then built a machine the size of 2 basketball courts to shape it, and then turned the battery itself into the actual skeleton of the car. What they came up with is so different from anything else on the road right now that it almost sounds like a video game stat sheet. But every number is real. Every claim is backed by the machines already running in their factory in Beijing today. And by the end of this video, you'll understand exactly how they pulled it off and why the traditional automotive world is scrambling to catch up. Let's start at the very beginning. The problem with every car ever made. Here's something most people never think about. The way cars are built today is basically the same way they were built in the 1950s. You take flat sheets of steel, you stamp them into shapes using giant presses, and then you weld all those pieces together. Hundreds of pieces, thousands of welds. It's been the same process for generations. Think of it like making a cardboard box. You cut out all the flat pieces, fold them into shape, and tape everything together. It works fine, but every single fold is a weak spot. Every piece of tape is a place where things can eventually go wrong, and the more pieces you have, the heavier and more complicated everything becomes. For a car, every weld point is a potential failure over time. A standard car chassis can have hundreds of individual stamped parts held together by hundreds or even thousands of welds. Each one adds weight. Each one vibrates slightly. Each one is a spot where noise can creep into the cabin. Engineers have spent decades shaving grams here and there, making the process slightly better and slightly cheaper. But the fundamental idea has stayed exactly the same. Then electric vehicles came along and made the whole problem even worse. An EV needs to carry a massive, heavy battery pack. The battery has to go somewhere, and the floor underneath the cabin is the most logical place. But when you bolt a giant battery box under the floor like a suitcase, it becomes dead weight. It makes the car heavier, which means you need a stronger and heavier chassis just to hold everything together. You end up needing more battery to move the extra weight of the chassis, which makes the battery heavier, which makes the chassis need to be stronger again. It spirals. Tesla tried to break this cycle in a clever way. Instead of stamping and welding dozens of individual steel parts together, they started injecting molten aluminum into giant molds to create huge single-piece sections of the car. They called it gigacasting. Instead of 60 separate parts welded together, you get one big piece straight from the mold. Fewer joins, less weight, faster production. It was genuinely revolutionary thinking. But it had one enormous problem hiding inside the metal itself. A problem that stopped every other manufacturer from copying it properly. And solving that problem is where Xiaomi's story really begins. The oven problem that stopped everyone. When you pour molten aluminum into a mold and let it cool, The metal solidifies, but the inside is actually